done by famous Professor Jan Vanthienen, and better known to this community as a decision table professor. And 3 of his PhD students created quite interesting presentation based on slides what I've seen. And it's about communication with decision model using natural language. And I expect we will see some interesting demo as well. So the floor is yours.
Hello, everyone. Hello, Professor. So today we are presenting a paper which we published in RuleML as well in the morning. And this is about a topic on communicating with decision models. So like moving forward, just let me start with an example to understand what communication means with decision models. So we have made a few decisions recently. One is a vaccination decision on what vaccination to take and when to take and how to take. So these all vaccination decisions are presented as a information for coronavirus in a Belgian website, and it is a good example to play with. So we took the rules out and we made a decision tables and the decision model out of it. So now when we see this decision model, which is a compilation of two sub-decisions and one main decision, and two sub-decisions are like, first is a face decision, which takes uses age and his employment and place of stay, and then based on that it determines a month of vaccination, and then using month of vaccination and the age, finally we determine what vaccination to take at the end. So you can see there are rules, and each decision table has one or more outcomes, and so this is a decision model formed out of a policy or a guideline. So now we can say...
I'm sorry, may I interrupt you? You don't vaccinate people after 100 in Belgium?
By default, we have chosen the age limit is to be 100.
But where is default? If in this table you don't have default.
Yeah.
Good point, Jacob. Good point.
A good point. So, and the other decision we have taken that took quite recently after getting vaccinated is the travel decisions, like where to go and which places are allowed to go, and if we go and when we return back, what is the quarantine and the testing decision we need to take. So we have seen there are countries and places divided into red, green, and yellow zones. And based on that, we created a very tiny, handy decision tables and decision models to understand this case. So here we can see there are like a country from which we are returning back, and if we have a Belgian residency or not, and also if we have a vaccination certificate or not, and how long we are going to stay. Based on these input parameters, a decision model can tell us how long we have to stay in quarantine and how many tests we need to take care of. For example, this highlighted rule says that if you're a Belgian and you're coming from a country with the EU code as a dark red, and you don't have any certificate, then you have to take PCR test once you come back at 72 hours, and then day 1 and day 7. And you have to stay in quarantine until the negative result is there. So like from these two decision models, we can see we are mainly trying to answer. Mostly these decision models are used to answer very general question, that is, given these inputs, what would be my decision? So like, for example, in the first example, the main decision we are trying to answer is, what vaccination can you recommend me? In the second one, we are trying to say, do I need to get tested or stay in quarantine when I return to Belgium? So these two questions are highly answered of an end user who is going to use decision models in either decision support applications or in any web applications. So like how basically we are trying to answer that is using a bottom to top approach, which we gather all the decisions, all the input informations at once, and then we try to calculate the sub decisions. Then we try to calculate the intermediate decisions, and then finally we present the end decision result to the user. So in this example, if a person is a 27-year-old healthcare guy and he's staying at home during the COVID time, then his phase decision to be likely to be phase 1 because he's working in healthcare. And then his month of vaccination would be February. And then finally, from the last table, we can say the requirements are matching to a vaccination called Moderna and the number of doses to be 2. So decision support will come up with an answer, take 2 doses of Moderna vaccination. But like if we try to if you want to convert this interaction with the decision model through means of a more interactive way, the ideal choice would be to go for a chatbots, because chatbots have immediate and personalized assistance, and they are very interactive in input gathering and also very friendly in output presentation, and they are more human-like, as if they are replacing a human health support or a customer support for a business. Or but what happens in reality is these chatbots, we might have seen the vaccination chatbots too online, but what happens is they tend to work on general answers like what is a vaccination and what all types of vaccinations. And if there is any user specific question comes in, then it tend to work around the answer and lead to refer to FAQ pages. So that is not exactly what user might want to have as an answer. And the construction and maintenance is also time consuming and very resource intensive when it comes to chatbots development. And also they are not really backed up with a very advanced reasoning. So there leads a void which we can fill in by connecting the DMN power of reasoning and with the chatbot power of user friendliness. So if we convert this DMN execution into a chatbot, it would look like this. Like we would ask a question and we would say that which decision he wants to pick, because DMN also offers, need not be the top decision. We can also play with the intermediate decisions. So if you pick the top decision, then it would ask serially one after the other input information which is required to make the decision. And then finally it presents with the decision value. And also we can tell the user that these are the intermediate decisions we found out for you. But there is one big problem in this case, that is conventionally asking all the input informations from the user one by one would elaborate a lengthy conversation. So that leads to a disinterest of a user. So, but there is also a solution in DMN itself, that is, if we want to ask an optimal number of questions to a user to gather information, that would be optimizing the decision tables. That either row order optimization and also column order optimizations keeps the most important values in the front in a tabular level, so that we can ask those questions straight away. And also, rather than going with the bottom to top information gathering, if we go from top to bottom information gathering, that's also one of the popular DMN execution approach, where we can try to optimize the average length of conversation by asking main important questions. I'll show you in an example. like in the given example, you might have seen, like here we can see if the person's age is 17 years, he falls in a case where there is no need of asking for a month of vaccination. So if we are trying to ask questions from the top to bottom, and the age, if it is 17, then we can cut down the conversation path and answer immediately that you take 2 doses of Pfizer. So that kind of conversation optimization will keep the chat or a conversation very compact, and the user will get more engaged. And for example, also, if a user knows the intermediate decisions outcomes, then we can also avoid asking the further questions down the tree and ask only the calculate the values of an end outcome based on whatever user knows. In this special case, if user already knows to be healthcare workers are given vaccination in February month, then we need not calculate phase and need not ask for his employment phase of stay. So that kind of compacts the length of a conversation, and that makes it more engaging. And these extra features are provided within the DMN execution using decision tables. But let's see if there are any other questions which we can answer through this decision tables. So user would always want to know more. So one, like he comes with follow-up questions, many follow-up questions once a decision comes in. Like for example, like why this vaccination is suggested to me. That means he's demanding an explanation. And also when he's uncertain, for example, when I'm retiring, what would be my vaccination? So means I'm unsure of a particular input information, then can I still make a decision? That is a background of this. And there are other questions too, like how many maximum days can I stay abroad without needing to go to quarantine after returning? That means user trying to optimize values, or this sort of questions comes in even loan sanctioning and also credit eligibility too. And also another common question user would tend to ask is, he already had a predetermined goal. For example, I have heard Moderna is better and I want to get Moderna. Can I get it or not? So such questions he has it. So these sort of questions, can they be answered with DMN or not? Let's see in the further slides. So like we want to, I think I spoke about this already. Let me move to the next slide. Yeah, so the key in this, key in answering these sort of questions is to understand what user wants to know. So user intents could be classified from our exercise of coming up with different questions for these 2 models. Is we found out there are almost 3 main intents of a user. One is to make a decision or to have a support in making a decision. And then he wants to seek a goal. That means he has a predefined goal and he wants to reach it. And the final one is once the decision is made, he wants to know an explanation how the decision is reached. So the key is, and the key for the better user experience in communicating DMN is understanding these intents and answering accordingly. Answering accordingly means DMN can be reasoned, decision tables specifically can be reasoned with multiple ways, like top down, bottom up. Incomplete information can be used with the wildcards. So these all reasonings can be appropriately matched with the user intents and can be played along to answer their questions. And see, for the classification of the questions can be seen in these ways. Initial intent would be, what is my decision? That is, in the 2 examples we can see, like if I'm 27 years old healthcare worker, what would be my decision? And in the second one, how to reach a particular decision, or can I reach a particular decision? How can I avoid testing and quarantine? So this is another question which can come from a user. And then explaining an outcome would be another set of questions. And also there is a experimental questions which would often come from users when it comes to healthcare support, or a customer support. That would be, what if I want to change my input information? Can I get something else? What if I want to change my destination from Spain to Italy? Can I still have the same quarantine policy? So these sort of questions comes very often in any online businesses or any customer support places. And also we have seen with each intent there would be a different expectation of an answer. One is like, when it comes to make decision, there could be user having a complete information or user having a relevant information. In both cases, decision can be made, and it need not be the case that we can stop the decision and say that we can't make it. We just want to try more and more until if we can surely reach a decision or not. So that is like, we try to ask a complete information, that is a basic case, and ask relevant information is also good case. And that in two cases we lead to a one particular outcome. And when there is a possibility of unknown information, when user don't know certain things like the destination where he's going, or the uncertainty of an employment, in those cases user can have a choice of giving unknown information case, and in that case the decision making still proceed with that and can come up with one or more possible outcomes. And there could be case that incomplete information, for example, user don't want to give any further answers, and he says that, okay, with the just given values, can you give me some details about the decision? So here in this case, like, rather than saying that, okay, decision can't be made, we can come up with a list of possible outcomes with a given value. And for example, in that vaccination example, if you want to if a user wants to know, he wants to just mention his employment but not his age, but he still wants to know what all vaccinations he can get based on his employment, that is still a possibility rather than giving a no as an answer. And then second sort of intent, as we've seen, is a seek goal. In this, there are like, user often wants to know what all conditions are required as an information requirements to reach a certain goal. So in this case, the desired answer would be a list of satisfactory answers. Similarly, there are other questions which comes as a follow-up questions that would be explain why. There often commonly used is like a list of rules that got triggered in a process of decision making would be given as an explanation. And then we have other important questions would be, what are the most important information items to make this decision, or what all information items which I can change to make this decision. So in these two cases also, there would be appropriate answers can be identified. So now looking at the a common like scenarios, we can divide the scenarios into like decision scenarios, and based on the intents to make a decision, and we can come up with the goal-seeking scenarios. Like the goal-seeking scenario is second one. Let me show you a small demo of how a goal-seeking scenario would work. So here we start with asking and bot to trigger with a start line, and then once it gets triggered, it offers us multiple options. Like basically there are three options here. One is to make a decision or to have a goal and to know the requirements of the goal, and then if he wants to know some additional information, then if I ask on I have a goal and I want to know the requirements, the value is asked to fill in for the desired goal. That desired outcome is vaccine. and it provides with an options which I can fill in for that vaccine. Then I would pick either Pfizer or Moderna. Then I proceeded further, and then it says it based on to get a Moderna as a value, it says that these all conditions to be matched, and these are the main inputs which needs to match, and these are the intermediary decision outputs that also needs to be matched. So if he uses criteria fall under one of these, then he would surely get a Moderna. And then once the model is done, like decision is done, we can choose to stop, and that's this small demo here. And that process is called goal seeking, which we tend to do from a top-down approach by looking through decision tables itself. Need not have a complicated reasoning, but just decision tables. So we pick up the Moderna as a final goal, and we see what all the conditions that are required to reach Moderna in the final table. Then we come up with the age constraints, and we also come up with some desired months to get to Moderna. And then we go look into the further next table to reach the months of February, March, and July. Then we come up with some more age constraints, and we come up with the phases as a phase constraints and conditions to reach phase. And then finally, when we look into the final table, we see that phases, all these phases are eligible to get Moderna, and all the rules are activated. But we can see there are overlapping conditions, which in the first table, it says that to get Moderna, it should be more than 18. So in the second table, it says, okay, 0 to 100 is eligible. So finally, when we try to merge these constraints, conditional constraints, then we can see that minimum requirement of age is 18 years. So this way we can come up with the come up with the condition sets which are satisfying to reach Moderna as a goal, and also we can come up with the minimum or maximum requirement of numeric inputs. And then let's see an explanation scenario example. And this is like when a user once he gets an output, he tends to ask, what is my here he again start a conversation. Then I think here I'm trying to take a decision from the starting, and so to keep it as a domain independent or a model independent framework, we can upload a chatbot at any before the decision. So once you upload a chatbot, once you upload a DMN, the chatbot picks up studies the DMN file and comes up with the options for inputs and the decisions. And then so here I'm picking up a vaccination strategy DMN, and then so what happened here was like it's already been loaded. So here we have some loaded DMN models. So when I pick up the decision table or decision model, then it asks that I have one top decision which I can take, or also I can go with the sub decisions which I can take. So here I pick up the vaccination which I want to take here, and then it asks series of inputs like starting with the age, and then it provides some possible options for each input, which is read from the daemon file itself. And then employment, here I would give others as an employment. Then finally, it comes up with an answer for the decision. And then it also comes up with the certain values which are used in between that are from intermediary decision. And after the decision is done, we have 4 options presented, and menu is like one is to do the decision again with different values, or we can explain this outcome. In this example, I would choose to explain this outcome. And yeah, I choose to explain this outcome. Then it comes up with the verbalization of a rule which got triggered. That is like using to get a vaccine as a Moderna, we have an age which is in between 0 and 48, and place of stay is at home, and employment is others. And yeah, this is the example for this. So we can present examples, we can present the explanations to the users depending on their decision outcomes and what they want to know. Sometimes they want to know further more information, like what if what if is a common question. What if my age is 49 instead of 27? Here what happens is, like, user doesn't want to redo the entire conversation, but he just want to tweak in one particular information item. So what plays role here is like keeping the context of a chat as it is, that is old inputs are maintained and the new input is added. So age 27, which was in a previous case and which is replaced with a new age, and based on that we rerun the decision making algorithm in the background and we come up with a new vaccination Pfizer. And then also user tend to ask other questions like sensitivity questions, what are the important inputs at the moment, like that. And we also saw that if we want to have a decision modeler as also one of the communicating person with the decision model via chatbots, then it would be interesting to see there are other questions that typically developers wants to know. That is, what is size of a model, what are the execution paths, and so on and so on. And these questions can also be answered if we have a validity check and other as a capabilities for the chatbot. Once again. Yeah, so we proposed a framework to come up with this algorithm, come up with this interactive chatbot just using a DMN. So that is like if a consistent, complete, and properly ordered like DMN is available with tables correct, then with that DMN can be loaded into a user interface. And this user interface triggers a menu option or a voice or a text options to interact with the DMN. And then once in the background, we have a different reasoning mechanisms which runs for decision tables are activated. And there is a dialogue engine in the center which takes the inputs. If the user picks up the question with an intent, and then through a menu option, it would be more clear to directly go to input processor, and input processor would trigger appropriate context to load a reasoner. And then reasoner would give an output, and that output would be generated as a response to the user. But there could be additional add-ons which are most needed for the chatbots in today's world, because chatbots runs with more of a voice and natural language. And in that case, we used additional external APIs such as NLP interpreter, which infer the intents. If user wants to say, I want to make a decision, or I want to make another decision, or I want an explanation, then or I have a goal. In these natural language sentences, the NLP interpreter would extract the user intents and also ask with the follow-up questions to extract the inputs, and then proceed further with input processing and reasoning. And that sort of natural language could come up with a text or a voice. And if voice comes, and then we use an additional module called speech to text. So this is a framework which we attempted, and we also came up with a heuristics of when to trigger what option. That is mainly like coming up with the menu options which are used by the user before the decision and during the decision and also after the decision. You can see like make decision intent is commonly seen before the decision, and explanation is another intent which is used by the users at the end of the decision. And so as I said, for the technical implementation, we used different external APIs. And for speech to text, we use IBM Watson API, which is most known for speech processing. And for intent interpreter, we try to use Microsoft Lewis as an interpreter. And for knowledge reasoner, we used commonly known decision table algorithms. We wrote it as a Python functions and used. And for the reference, we suggest to look into the paper which we published for more details on technical implementation. And yeah, this is one of the demo. I couldn't make a video for this, but like what happens is when we give natural language sentences, the intent understanding process is triggered, and the intent understanding process uses a Lewis platform which extracts intents, and which also extract the scores of the intents, and which also, along with intents, it extracts entities such as age. In this query, will I get a Moderna or Pfizer? My age is 27, and using that we can automatically trigger the corresponding reasoning mechanism to answer those questions. And this can be given in a voice, and we will come up with the corresponding output to ensure that the user audio is correctly heard and the intent is correctly understood. So this is one thing. And finally, we wanted to evaluate this decisions using decision support chatbots using like 6 dimensions. One is the comprehension, and then reliability, user engagement and maintenance and speed, functionality and scalability and interpretability. We see the reliability is not a commonly used criteria for chatbots, but since we are using a DMN, which is a human-built decision model, and which is reliable and fair, so we can add that dimension also evaluation criteria for the chatbots generated. And of course, there are the chatbots are not fail-proof, and they tend to, in this case, they tend to depend mostly on quality of the decision model itself. But that's not the main challenge. But the challenge is the decision. We haven't yet explored into other forms of decision logic, such as field expressions or a functional logic, and we relied on decision tables itself. But the advantage side is with the decision tables itself, we can answer most of the possible questions. And for the future work, we want to make sure to work on this limitations. And we also want to try integrating with advanced reasoners such as IDP. You can follow up the talk of Simon tomorrow, and he's going to discuss further on like on advanced reasonings on DMN with IDP. And also we want to do thorough evaluation of the dimensions which we proposed, and we want to investigate and compare other declarative knowledge formats also to see if they empower the chatbots in this dimension. Finally, there could be an answer. Okay, what happens to the questions which DMN cannot answer? Of course, users comes up with the crazy questions, but not crazy, but curious questions. But in those cases, we can always refer to FAQs like the current chatbots are doing, but we are able to answer more than what they are doing. And final conclusion is we see this is the first time attempt to convert a DMN into a chatbot to take the decision knowledge more closer to the end user in terms of reliable explanation, reliable decision making, and explainable outcomes. And this we try to keep it more user centric because we centered user intents as a core of this framework. And we also tried to answer most of the questions using a decision tables itself. And finally, there is a lot of potential in online businesses when it comes to chatbots and also decision support systems. And this is the end of my sorry, not the chat, but the presentation. And if you have any questions.
Okay, thank you, Vedavyas. It's there is a comment from Jacob over in the Slack channel about what a great idea this is, that instead of executing a decision model, you're actually using it as input to build the dialogue or the chatbot, so that you're asking only the questions that are needed. So it's kind of a turnaround from what I think a lot of people are doing with DMN. So do we have any other, do we have any questions from the other attendees here? If you're on Zoom, you can put your hand up on Zoom and I'll call on you. You can ask your own question, or if you're shy and want me to read your question, you can enter it on Slack and I will get to it there. Okay, Bob, go ahead.
Well, I just get myself talking. No, I mean, one of the questions I guess I had was how easy is it to use the rules in the decision table in kind of different directions? I mean, to put it into context, I always have mixed feelings about using decision tables as a solution, because I've always found that if you actually kind of just treat the rows as almost like a relational table in a database, then you don't need to sort of think, oh, this is the output, these are the inputs. You can actually very easily say, what inputs do I need to get for this output? Because it's almost just an SQL query. So I'm kind of wondering a little bit about how you're actually doing that sort of reverse engineering within the context of decision tables, or you know, how you go about that.
So compared to relational databases, the decision tables can be also they have a idea of backward reasoning from the outcomes to the desired inputs, and from the desired inputs, if they are dependent on another tables, which we can also, like, of course it's like a foreign key approach in a relational databases, but we can still use the similar principles here in decision tables to identify if the table, the input condition is coming from another table. We need to find the optimization version, optimal conditions for that. It's always like a backtracking from the out. If it is a seek goal as an intent, he have to backtrack until.
Yeah, no, I guess the thing is that if you look at particularly the way that the DMN expresses decision tables, it does it in a kind of directed manner. So you have the input columns, you have the output columns. Whereas if you take it more as, if you take it more as something like a relational table, then all the columns in effect are equal, and then
yes,
you'd sit on top of that your business rules, which then say, well, actually, in the context of what I'm trying to do, I want to use this column as an output and these other columns as input. And so you're essentially treating the relationship between the inputs. You've almost lost the relationship between the inputs and the outputs, and you're basically just saying, these are connected pieces of information. And sometimes I want to use this as the output and these as the inputs. And sometimes I want to do it a different way around. And so it's really kind of throwing away, or rather than throwing away, but basically not having embedded in the decision table the way that you actually want to use the related pieces of attributes, but abstracting that and using that's a separate piece of knowledge which manipulates these relationships.
Go ahead. Is there a response, or is that Bob just giving an opinion?
Well, I mean, I guess it's more a matter of more a matter of ultimately comes down to a matter of implementation mechanics, because the thing is, if you want to look at the relationships between the objects in different ways, do you end up in a situation where you're basically replicating those relationships in several different places because you want to go into them from different directions? Whereas if you use it where you essentially just say, these are the relations, and then I have some logic which says how I want to make use of those, then you only have one source of truth about what the relationships are.
Yeah, you're right, Bob. It's one source of truth. Of course, we use tables in a specific way. We don't use all different types of tables, and that helps to do the reasoning. Of course, the unique tables and the simple tables are a little easier to work with than all these weird forms of tables. That helps, of course. But you can read tables in different ways, from left to right, or from right to left, or top down, or bottom up. It doesn't matter. It's one source of the truth. Or one.
Yeah.
There's an interesting question on Slack that I think is a little bit related from Ron Ross about whether the textual expressions or the questions, are they handcrafted or are you automatically generating those? Like, so what are you getting from the tables and then what appears in the chatbot?
Yeah, so that's an interesting question. Like, maybe I haven't stressed enough on when I said I'm using Lewis in the background. It's a language understanding tool. So what happens is we try to propose this framework in 3 levels. First is menu options, which are handcrafted. So which guide the user to pick up a choice which explicitly mentions the intent. And using the Lewis is when user don't want to use the menu options, he can also try with different language queries. Of course, they should be short and they should be synonymical to the queries that we already have trained. So in the case of the matching intent, then we say that, okay, this query, the new query, which we haven't shortlisted or whitelisted before, can also imply the same intent of the user. So we are trying to face that limitation, address that limitation by using the Lewis, keeping it not too handcrafted or not too monotonous throughout the conversation. So he can play with the queries. I hope that answers the question.
Okay. Well, Ron can always jump in with a follow-up if need be. But Denis, I'm going to call on you. You have your hand up now. You have to unmute, Denis.
Why?
There we go.
Why? Why do I have to unmute?
Well, you could just go like this.
Yeah, that's what I've always been doing for the last 30 years. So if I understood correctly, basically the first thing that chatbot does is decide on intent, and then based on intent, you will use a different rule execution strategy to match that particular goal there. And to what Bob was saying was that, well, if you're only using tables as input, then you can use that same structure by just playing by the meaning of the rows to do the execution strategy, basically, to have a more generalized reasoner. Because it sounded to me, it may not be the case, that you have 3 different reasoner for each of the case. One that was more forward chaining, one that was backward chaining, and one that was constraint satisfaction to do. So I'm trying to see where you see the challenge, because as you just mentioned at the end there, figuring out the intent is itself a learning problem to be able to get out the intent and the entities correctly. And then, so that's a challenge on its own, which could also be expressed as decision models. And then you have the actual content, the knowledge, which is what you need to run. So I guess my question is, do you see that as a better way to generalize DMN in terms of having different way of reasoning about the same knowledge? Naturally, the rest of field expression will become a little bit tricky. But for decision table, because of all the attributes that Bob was saying, then you have the flexibility of flipping the rules around. So depending on the kind of reasoning you do, you have more flexibility. Have you started exploring with other field expression, to see how that will impact this selection of the reasoning algorithm?
We haven't yet, but that's one of the direction which we want to look into, because it kind of limits if we just stick to conventional decision tables. In case of expressibility, most of the decision sometimes comes as a field expression without much of an input and output, just like a conditional format as a boxed expression. So in that case, this logic might not be relevant, but we have to come up with something else, maybe like advanced reasoning in case. And for that, to keep this approach more flexible, since we are relying on APIs, if there is a Camunda or Signavio API, which open rules API, which runs on the field expression, which can solve that table, then we can connect and with that, and we can solve it and present to user. So need not stick to the algorithms we are using for decision table.
Yeah, and that's the typical pattern we've seen of our clients using chatbots in front of decision. Is in their case, the chatbot was basically just calling the decision service and providing answer back. I think what you're doing is much more interesting because then you're making the chatbot a little bit more intelligent in selecting the right reasoning strategy given the intent of the person interacting. So very nice work.
If I can add something, but everything has been said, but it's not only about decision making, but there is an entire service industry and help desk industry which is dealing with phone calls. What do I have to do? What do I need? And so on, which is 80% of the problems. And in DMN, we didn't solve that problem because we only did decisions. And now we are in the answering business or the question business and the service industry. And there's big business there of people calling, what do I need to do? And what are the important factors? And why do I get this? Why do I not get a loan? All those questions. And this is just an attempt to start this, say, business or to start this industry, because I think it's a very huge industry. And this is only a start, but we can go a long way there, I think.
Exactly. And there was an interesting question on Slack from Rohan asking if AI could then be used to evolve the decision models. So it's like, I realize that's a little different from the research you're doing, but what could be done now to start to take, you know, some of the answers that you're collecting and so on, and then using AI to evolve the models?
Yeah, sure. Of course, we do not always need to make it too complex. There is so much silly laws and easy laws with lots of questions. We don't even need AI to answer the simple questions, but we need to automate the simple questions. What do I have to do to get this? Why do I not get this amount for a premium, a pension, a wage, and so on? We don't even need AI to do this. We need a simple chatbot and a simple DMN model.
Right. Although I think the question was about using AI to then evolve the decision models themselves.
Then you can.
Yeah.
Yes. Hello. I am Alexandre Goossens. I am also the co-author of this presentation. I would like to answer on this AI question, but I'm not sure whether it's always desirable actually to let sometimes people outside of the decision itself influence the decision. There are plenty of examples of chatbots on Google where when it learns from the outside world that the final chatbot is horrible. Yeah. So I think it makes more sense the decision model stays where it is supposed to be, being in the hands of the experts, and then you can play around with it internally with your company. But I would not let, for example, the customers decide on the conditions of the bank loan for your bank.
Oh,
I
would
think
be a
that's
good idea. Would be a good
I
idea.
think that's an excellent point. Yes.
yeah. But I think maybe AI is good for a lot of things, but sometimes it's good to keep it in our human brain. Yeah.
Maybe if we just own a developer's mode into Chatbot, maybe we can try to give some instruction to Chatbot to modify the DMN or add a rule to a table. Those things can be done maybe intelligently, or maybe we can just change the DMN files through commands, verbal commands or speech commands.
Yeah, I
that's
think
interesting
the other question to ask is how you're going to use AI to evolve and improve the system. I mean, for example, it probably helps if you could use it to, sort of pick out things like the sorts of ways people are asking questions and actually improve the way that that's done. I mean, you're not going to change. You can't change the regulatory control which says this is the way that we're going to hand out vaccines, for example, but you could improve the way that the system interprets questions so it can be a more responsive to the sorts of interactions that you have. It's not changing the actual decisions, it's just improving the way that the sort of experience of the user is in actually getting to the answers that he's looking for.
Okay, let's take one last question from Denis. You have your hand up, and then we're going to have to close out the session after that.
So you're going from DMN to the chatbot, so you're going from a fixed language to a specific system, I imagine, because there is no standard for chatbot, quote unquote, programming. So then your interpreter is really chatbot specific. Is that correct?
And chatbot specific for sure, but not a model specific. So of course, this chatbot has identified few intents, and it is trying to expect the queries around these intents.
That's not what I meant. What I meant is when you're inputting your DMN model into the chatbot so that this becomes the context of the chatbot. The context of the chatbot is platform specific, because each chatbot platform uses a different way, like depending on which chatbot platform you use, this mapping will be different, given that they're not standard. So unless this is also in, which I haven't seen, so I guess let me put that in the form of a question. How do you see generalizing that transition from the DMN model to the chatbot platform? Because I'm assuming right now it has to be specific.
Rather easy, because we use different chatbot platforms, actually. The logic is completely separate, so it's only the interface part or the interface generating part which is platform specific, and that's a minor thing.
Oh,
yeah.
Okay. Oh,
So
well, then I'd like to interact more because there's something I'm missing.
Yes, and also DMN file itself is a XML format. So the XML format is parsable quite easily in whatever the API we can convert. Most of the chatbot APIs like Telegram, Facebook, WhatsApp, they use a JSON-based REST API conversations, and to converting from a DMN XML to JSON file is quite easy. So then it makes that APIs can be swappable in the framework.
Yeah. Actually, we did this with students, and some of the students used Telegram and some of them used another chatbot. And that was not a hard part. That should be easy. Yeah.
Well, that's good. Well, that's all we have time for. Vedavyas, you must feel like you're defending your PhD thesis here, so you've done well on the spot here.
Good job, Veda.
Yes, good job. So we're going to we have about 6 minutes, and we're going to start at the top of the hour with the Ask a Practitioner panel. Let's see, I'm going to stop your sharing, and then I'm going to share. And we can, assuming I can find my slide, there we go.